Hello guys, welcome back. So in this video we are going to understand the second question for the Leetcode contest problem 470, right? So let's try to understand what we have given here. The contest question is saying that longest subsequence with non-zero bitwise XOR. Okay, means we have given array, let's suppose nums, and we have to return the length of the longest subsequence in the nums whose bitwise XOR is non-zero. So I will make sure that if you are afraid of what is this bitwise XOR and these things like the longest subsequence, those, so please don't be hesitate, please stay here and keep watching, because this is very simple problem. You don't need to be afraid of this type of problem. This is very simple. It is a medium, but I will suggest this is very simple. Once I will explain, you will understand that this is very simple. Okay, so try to stick to the video, and if you still have any doubts, please ping me in the comment box. I'll definitely will help you there. Okay, the question is saying that if no such subsequence exists, right, we will return 0, right? So the question is saying that we have given these nums, let's suppose, and the output is coming 2. Why? Because the longest subsequence is 2 3. If you take the bitwise operator, let's suppose 2 XOR 3, it will come 1, which is a non-zero, right? So if you will take all of these, right, it should not come the non-zero, it should not come as a 0, right? It should, if it is coming such that, let's suppose, you will return 0. Okay, let's very first understand. Very first, what I'm saying, bitwise XOR. What is bitwise XOR? So bitwise XOR is also known as the exclusive OR. It is a bit level operation, right? We know the bitwise XOR. If you are doing the BTech of your past already, if you have experience, still you know the bitwise XOR. So bitwise XOR is a bit level operation. So it compares two binary numbers bit by bit, and it returns 1 if the bits are different and 0 if they are the same, right? If you know the truth table, when we see the different values, it will return 1, otherwise it will return 0 in the same case. Let's try to understand the truth table. You know there is A, B, and the operation XOR. So when you will take 0, 0, obviously these are two the same, you will get the value 0. Again, you will get different value 0, 1, 1, 0, you will get 1, 1. Other than 1, 1, you will get 0. So when it is coming the two values 0, 0, 1, 1, you will get 0, 0. In the different cases, you will get 1, 1. This is what we know about the bitwise XOR operations, right? It is a bitwise level operations where we compare two binary numbers bit by bit, and it will return 1 in the case if they are different. In other cases, it will return 1, right? In the same cases. So this is what we talk about the XOR operations, right? Very first, let's suppose the two numbers we have, and how we are going to compare the two numbers bit by bit, right? So how we are going to compare, let's understand. So if we represent this 5 into the binary system, it will work like 0 1 0 1. You know the formula 8421, right? If it is more than that 4 bits, you will go to the 16 bit, right? Means 16 8421, right? Like that we have. So if you compare this value, right, if you represent the value in 5 into the binary, it will look like this. For 3, it will become 0 0, and this is 2 1, so it will become 3. So now compare the value. These 1 and 1 are same, right? When we get the same, we'll get the 0. When we talk about 0 1, right, these two are different. So when these two are different, we'll get 1, right? When we talk about 1 0, it is also different, we'll get 1. These two are same, we'll get 0. So we have performed XOR operations. Sometimes we also represent like this. Sometimes you also see in the books like this, right? So don't be afraid of this type of things. This is just a XOR operations. When you perform the XOR operations, right, you will get something like this on these two numbers, right? You will get the 6. Means if you will take the XOR of two numbers 5 and 3, you will get 6. In Java, let's suppose how we'll write the code. So you will write int a equal to 5, b equal to 3. Let's suppose we have these two numbers we have took in a variable a and b. So int c will take as a XOR b, you will get the value c. When you print the system order println c, definitely will get the 6. This will be your output. So we will say, what is the XOR properties? XOR properties are very definite, right? So if you'll understand some properties of the XOR is, let's suppose a XOR 0, it will come a. When we talk about a XOR a, both are same, you will get 0. In this case, it's still different, but this is, we are taking the XOR with the 0, it will come A. If we'll take A and B, it is equal to B and A, the definite value will come same in both condition. This is the cumulative property. Okay, when we talk about A and B and then you will take with the C, means this resultant of A and B, you will take the XOR of A and B and the value will come as a result that you will take with the C. It is exactly same as A, and the B and C resultant, right, you will take with the A. It is same as in both cases, and this property is called associative property. Okay, similarly for these cases, right, A, B and C, you will get A. This is very useful when we talk about the many algorithms in the DSA, right? So definitely the problems comes when we need this type of things. So this is very useful. I'm saying this because you should understand. If you are following expert funda, you should know the XOR in detail. Let's talk about some use cases, right? When we talk about where we'll use the XOR, right? So when we swap the two numbers, so swapping of the two numbers without a temp variable, you know how to do the swapping. You use the temp value very first. If you'll take A and B, you will put A value into a temp, and then you will put the A value will be come from B, and then you will add the B from the temp, right? And then you will update like that. So you don't need to do that. You just need A. You will take the XOR of A and B, you will store at A. When we talk about B, you will take A and B XOR, again you will store in the B, and then again you will take A and B XOR, you will get A. Means in this way you will do the swapping. Actually this happens because when we take B equal to A and B, right, it happens like this: A XOR B, and then you're taking the B, means we are getting the A, right? So this resultant is nothing but this one. Similarly for these cases, you will do like this and you will get the value of A. Okay, so when we talk about the find unique numbers in the array, then obviously we will use the XOR operation. So if every numbers appears twice except the one, and you want to find the unique numbers, in that case you will also use the XOR. So the duplicate pairs cancel out XOR. Let's suppose X and X, you will get the 0 and you are left with the unique number. So you just need to take, let's suppose you will take the result 0 and you will make a for loop of the elements, and you will take what resultant value you will take with the mod, you can say the XOR equal to nums, and you will get the resultant. So I'm not diverting from the main questions, we'll come back here, don't worry. So the question was given is, let's come back to here first. This is what, guys, we talk about the XOR, so don't need to worry about the bitwise XOR. Okay, the question is saying that the longest subsequence with the non-zero bitwise operations, and these are the things we have given. You can pause and you can read again. Okay, let's come back to the problem. So problem, what we have given a non-negative integers that we have seen. We may pick any subsequence, will keep a relative order, but XOR doesn't care about the order. So we'll compute the bitwise XOR and we'll pick numbers. Okay, so we'll return the maximum possible length of subsequence whose XOR is non-zero. If no such subsequence exists, we'll return 0. Okay, what we have given a non-negative integers that we have seen array, and we may pick any subsequence, right? Why we'll take any subsequence? We may pick any subsequence. We want to keep the relative orders, right? But here problem is that when we do the XOR, right, XOR doesn't care about the order, right? And we'll compute the bitwise XOR of the picked number. So very first we have to pick the numbers and we'll do the bitwise XOR. So when we'll do the return, when we'll return the maximum possible length of the subsequence, right, whose XOR is non-zero, so we have to return the maximum possible length, right? We'll know how to do that, don't worry. If no such element is there, will exist with a 0. This is what the problem is saying. So I will suggest pause this and try to read 2 or 3 times so you will understand. Okay, now here the order doesn't matter for the XOR that we have seen. So the subsequence V as subset is irrelevant, so you don't need to focus about the subsequence and subset. The trick is you will compute X, right? How? You will do the XOR of all elements. How we are going to do? You will take nums at 0, XOR nums at 1, and so on. You will do until the n-1 element, and you will get the resultant in the X, right? You need to check if X not equal to 0, the XOR of the entire array is non-zero, correct? It means the resultant is not getting the 0, means all the elements are not same, it is coming somewhere is different, right? It means you will never get the x is a 0, right? So it is saying if x not equal to 0, the XOR of the entire array is non-zero, correct? So the longest subsequence is the whole array, so we will return the answer as a length of the array. If x is equal to 0, means there are some elements, or you can say the all elements, XOR of all the elements is 0, means we have to remove the elements num set I, and will leaves XOR of what 0 and num set I, you will get the value num set I. Some means all the elements you will apply here and you will get the XOR, right? So if there exists any number which is not equal to 0, we'll remove that elements, and that gives you the XOR not equal to 0. So if any elements coming, if any elements gives the 0, means we have to remove that 0, right? So that we will get the XOR value not equal to 0, means any element is giving 0, you will have to remove it. So we can take n-1 elements, and in this time we will get the n-1 element, correct? So if every element is 0, so all the nums at I equal to 0, correct? So so no subsequence can have non-zero here, and this time we'll get the 0. So if every element is 0, obviously we will get the 0, because all should not be the unique, and any number you are taking as 0, obviously it will come as 0. So these things you have to cover in the example, right? All these tricks you have to cover in the examples, okay, in the code, you can say. If you try this approach, definitely you have to traverse through all the elements, you will get O of n. For the space, we are not taking extra spaces, right? We will take the XOR operations only, you will get O of 1 as a space time. Let's talk about this code. So as I told you, we'll take the x XOR for all the elements. What you need to do, you will iterate over the elements, right? All the elements, you will take the XOR vs the element, the value of the each element, right? You will do the apply the XOR. What you need to do, if you will say if v not equal to 0, if the value is not equal to 0, you will say any non-zero is equal to true, correct? So in this way, if not any value is not equal to 0, means there is no 0 value is there, means any non-zero will set markable to as a true. There is non-zero element is there, no element is 0, and that is why we will mark it as true, because initially we will take the false. Now what you need to do, you will say okay, now XOR not equal to 0, means the whole array working fine, will return n. So the whole array works fine, correct? Then we'll take if any non-zero is there, return n-1 element. So we'll remove the one non-zero elements, and we'll say okay, if non-zero element is true, means there is one element which is 0, will return n-1 element, okay? In all other cases, means definitely there is a 0, right? All are zeros, so you will return 0, which is impossible, okay? So this is what you need to write the code, and it will definitely work. But still, if you have doubt any bit of the code here, any explanation there, let me know in the comment section, guys. And if you want the structure way of preparation in the FANG preparation, the product based company, please ping me in the comment box, or you can reach out to the WhatsApp number in the given descriptions of the this video, and you can reach out to me. And definitely this is minimum cost, and you can do the preparation on the structure way, because preparation of the DSA is really difficult. You should have some instructor, or you can say some course, so you can properly work on that, or otherwise it is very hard to track where you are. Thank you guys, thank you for watching this video. In case if you need any help, please ping me in the comment box. Till now, bye bye, I'll see you in the next one.